Assalamualaikum and good day to everyone. So we're going to continue with single degree of freedom system, and now we're going to focus on free vibration of undamped translation system. Alright, so basically to develop the equation of motion, so we use Newton's second law. Okay, so basically we need to draw the free body diagram, and then we apply the Newton's second law of motion. Okay, so for free vibration of undamped translation system, to develop the equation of motion, okay, the Newton's second law for translation system is sigma f is equals to mx double dot. Okay, this is for translation system, but for torsional system or rotational system, it is sigma moment equals to j theta double dot. Okay, so j or I. Okay, and what's the difference between those two? So for translation system, it consists of spring and mass. Okay, and for torsional system or rotational system, it consists of a disc, shaft. So this is KT, torsional stiffness, and this is J, which is the second moment of inertia. And if translation system, we use X. For torsional system, we use theta to represent the coordinate. Okay, so if sigma f is equals to mx double dot, okay, for translation system, and for torsional system, we don't use f, we use m, moment. Okay, so summation of moment is equals to the multiplication between second moment of inertia multiplied with theta double dot. Okay, so we don't use x, we use theta double dot for torsional system. Alright, so now let's focus on translation system. Okay, so this is the equivalent spring mass diagram, and then when we draw the free body diagram, so it becomes like this. So if you can see here, since we don't have any external force, okay, so this is the case for free undamped vibration system. So this is the free body diagram for free undamped vibration system. And we already know that for free undamped vibration system, the equation of motion will become mx double dot plus kx equals to 0. So it doesn't have any external force, and it doesn't have any damping coefficient. And other than we use Newton's second law, there are also other methods to develop the equation of motion. For example, by using the Undamped principle, principle of virtual displacement, and we can also use principle of conservation energy, or also known as Lagrange. Okay, so basically you will look onto this on chapter 4, multi-degree of freedom system. So in chapter 4, we will look on how we develop the equation of motion without the needs of using free body diagram and Newton's second law. Alright, so for free undamped vibration system, okay, so if you refer to the solution or the response on the last 2 pages of your lecture notes, okay, so this is the solution or the response. So when I mention response, okay, if you remember in chapter 1, okay, so for vibration we have 3 types of response, or the response can be represented to 3 different cases. So if I mention response, vibration response, so we know that it can be in terms of displacement, whereby the unit of displacement is meter, and it can also be represented velocity, and the unit is meter per second, and it can also be represented as acceleration, or x double dot, whereby the unit is meter per second squared. So if we have the solution in terms of displacement, for example, in this case, okay, so this is the displacement response, or the response in terms of displacement. So how do we get the velocity? So we know that velocity is x dot, meaning that we need to differentiate one time, or first order differentiation. So if you differentiate x over time, we can get x dot. So if we are considering free undamped vibration, whereby this is the response, so if we differentiate it x dot t, okay, so we will get negative omega n a1 sine omega n t plus omega n a2 cos omega n t. Okay, so if you differentiate xt, we get x dot t, which corresponds to the velocity, and this is the solution. Okay, so if I differentiate this again, okay, or second order differentiation, I can get the velocity. So x double dot t is negative omega n squared a1 cos omega n t minus omega n squared a2 sine omega n t. Okay, so if I differentiate this again, I will get this equation. So this is the type of response that we can use. Okay, but basically first you need to know what kind of vibration that you're considering, whether it's free vibration, forced vibration, free undamped vibration, forced undamped vibration. So you choose which response correspond to the cases that you're considering, and then when you differentiate, you can get it whether x dot t or x double dot t. So in order to differentiate this is where what you learn from differential equation is important. So for those who are struggling, please look back on your notes on how to differentiate, for example, cos, sine, okay, e to the power of x, and so on. Alright, now we are considering the free undamped vibration system. Okay, so what we want to solve is that basically from this response, what we want to determine is we want to determine the unknown. Okay, for example, if the question asks you find the displacement at 5 seconds, so if it says find the displacement of vibration at 5 seconds, so meaning that what you need to identify is that you need to identify the x when the time is 5 seconds. So meaning that it becomes a1 cos omega n multiplied with 5 seconds plus a2 sine omega n 5 seconds. Okay, so in order for you to determine the displacement at 5 seconds, okay, you need to know what are the unknowns. Okay, so what are the unknowns? Meaning that you need to determine what is a1, what is the omega n, and what is a2. Okay, so in order to find this a1 and a2, we need to use initial condition. So basically a1 and a2, we can determine it from initial condition. So what does it mean by initial condition? Initial condition means we need to consider x when the time is 0 second, and also the x dot when time is equals to 0 second. So sometimes we can write it as x naught, meaning that initial condition, displacement, and x dot naught, initial velocity, initial condition for velocity. So naught here means when time is 0, right? So before we go on how to determine the A1 and A2, maybe we can do a bit of recap. How do we determine omega n? So since now the case is single degree of freedom system, to determine omega n is square root k over m, where k corresponds to the stiffness coefficient and m is the value of mass, and omega n, the unit is radian per second. Alright, now let's continue on how do we determine A1 and A2 by using the initial conditions. So for free undamped vibration system, we know that the response is xt is equals to A1 cos omega nt plus A2 sin omega nt. So where can you get this equation of the response? You can refer back to the last 2 slides of these lecture notes. So we apply initial condition, okay? So x when t is equals to 0 second, or we write it as x naught, and x dot t equals to 0, or we write it as x dot naught. So now we know that we need to replace when time equals to 0 to this equation. So we need to put this as 0, this as 0, and this as 0. Okay, this is with the first initial condition. Okay, and when we want to consider the second initial condition, okay, you need to realize that this is x dot, this is no longer x. So meaning that we cannot replace t equals to 0 on this equation, because this is not x dot. So what we need to do is that we need to differentiate this equation. So x dot t is equals to negative omega n A1 sin omega n t plus omega n A2 cos omega n t. Alright, so as I mentioned earlier, why we use this initial condition is because we want to determine what is the A1 and A2. So this is where we use the initial condition. So how to use this initial condition? Again, what we're going to do is that we're going to put t equals to 0 to this equation, and t equals to 0 for this equation. Okay, so this equation will become x naught, because x when t equals to 0 is x naught. Okay, x naught is equals to A1 cos 0. So cos 0 is 1. Okay, so you learn this in mathematics, plus A2 sin 0, because t is now 0. So sin 0 is 0. So A2 multiplied with 0, all of this will become 0. So in the end, what we get is that x naught is equals to A1. Okay, or A1 is equals to x naught. Okay, this is when we consider the first initial condition. So when we consider first initial condition, we can only get A1. We cannot get A2 yet. So in order for us to get A2, okay, this is where we use the second initial condition. We replace the time equals to 0 on this equation. So when time equals to 0, so meaning that sin 0, so sin 0 is 0. So this whole equation will become 0, because 0 multiplied with something we get 0, right? And x dot t equals to 0 is x dot naught. Okay, because what we're trying to do here is that we replace time equals to 0. So x dot naught, or x dot when t equals to 0 is equals to 0, which is this one, plus omega n a2 cos omega n, time is 0, so cos 0 is 1. Okay, so we will get omega n a2 multiplied with 1, so omega n a2. Okay, and remember what we're trying to define now is we want to determine the a2. So a2 is x dot naught over omega n. Okay, so now we already know that a1 is equals to x naught and a2 is equals to x dot naught over omega n. So we replace back in this equation. Okay, so it will become xt equals to x naught, okay, why x naught? Because a1 is x naught cos omega n t plus a2 now have become x dot naught over omega n, so x dot naught over omega n sine omega n t. Okay, so this is the response or we have already identified what is the a1 and a2. So in question, normally it will give the question will provide you with what is the value of x naught and what is the value of x dot naught, and omega n you can find it from square root k over m. Alright, so this is if we want to identify what is xt. Okay, if let's say the question asks you to identify what is the x dot t, so x dot t will become negative omega n a1, so a1 is x naught sine omega n t. Okay, so from here plus omega n a2 is x dot naught over omega n cos omega n t. So if the question asks you, okay, find x dot when time is equals to 3 seconds. Okay, so if you already identify what is a1 and a2 and the question already provide you with x naught and x dot naught, so you can straight away replace this with 3, because the question asks us what is x dot at 3 seconds, and replace this with 3. Okay, and this one, as I mentioned earlier, we can find it from square root k over m, and x naught and x dot naught will be provided in the question. Okay, so what I want you to do is that try on your own how to determine a1 and a2 from the by using the initial condition. So similar to this, okay, so xt is equals to x naught, which is a1 cos omega n t plus x dot naught over omega n, so this is the a2. Okay, try to do it on your own. Okay, from basically from here by using the initial condition, try on your own how you can get this equation. Alright, thank you very much. So we will continue our next session with free vibration of undamped torsional system.